All right, welcome back to our deep dive on VLANs. In the last couple of explainers, we figured out what VLANs are and how we use access ports to get devices into them on a single switch. But today, we're going to tackle the big one, the question that really unlocks the true power of VLANs. So that's the big question, right? How do you get these VLANs, these separate little virtual networks, to actually stretch across your entire building, your whole campus even? That's the puzzle we're going to solve right now. Before we get to the solution, let's just make sure we really nail down what the problem is here. And it's actually pretty simple when you think about it. We have one single physical cable connecting two switches, but we need traffic from a whole bunch of different VLANs to get across that link. How is that even possible? Okay, so picture this. You've got switch A, that's for the HR team, and they're all in VLAN 10. Then over there is switch B for the IT department, all in VLAN 20. And connecting them is just one single Ethernet cable. So how in the world does that one cable carry all that traffic for both HR and IT, but still keep it totally separate? I mean, if we can't figure this out, VLANs are kind of useless once you have more than one switch, right? Now, your first thought might be, hey, why not just use an access port? We already know how those work. And, that's a perfectly logical question to ask. But as we're about to see, access ports have this one huge limitation that just makes them the wrong tool for this specific job. And here's the thing. It all comes down to this. An access port's one and only job is to lock a connected device into one single VLAN. That's it. It's a one-to-one deal, and that's exactly why it won't work for connecting our switches. So look, if we set up that link between the switches as an access port for VLAN 10, sure, all the HR traffic would sail right through, no problem. But the second a frame from the IT department from VLAN 20 tries to cross, the switch is going to look at it, say, nope, you don't belong here, and just drop it. It's a total dead end. So yeah, we clearly need something else, a port that's a bit smarter. And that, my friends, brings us to the hero of our story today. It's time to meet the trunk port. So what is a trunk port? Well, unlike an access port that's stuck with just one VLAN, a trunk port is a total game changer. It's specifically built to be a multi-lane superhighway, carrying traffic for lots of different VLANs at the exact same time, all over one single physical cable. Okay, but wait. If a trunk port is a superhighway with cars from HR and IT all driving on it, how does the switch on the other side know who's who? Right? How does it keep all that traffic from turning into one giant mess? The answer is actually the super clever, super elegant process. It's a little bit of network magic, and it's called VLAN tagging. Now, of course, this network magic has a proper technical name. It's the IEEE 802.1Q standard. And honestly, the idea is pretty simple. Before a piece of data, a frame, gets sent across that trunk link, the switch literally injects a little digital tag right into its header. And that tag is just a label that says, hey, this frame, it belongs to VLAN 10, or this one over here, that's for VLAN 20. Now, this is absolutely crucial to understand. This whole tagging thing, it's completely invisible to your computer. Your PC, your laptop, they have no idea what a VLAN tag is, and frankly, they don't need to. It's all handled by the switches. They do all the heavy lifting, adding the tags as data goes onto the trunk and stripping them off before it gets delivered to a computer. So let's follow one piece of data on its journey. The easiest way to think about this is like a luggage tag at the airport. Okay, so first, your PC sends some data. It has no tag, it's just your luggage. Second, when it hits the first switch, the switch slaps an 802.1Q luggage tag on it saying, this is for VLAN 10. Third, that tagged piece of data travels across the trunk, the flight. Fourth, the switch on the other side gets it and immediately reads the tag. It knows exactly where this luggage is supposed to go. Fifth, it rips the tag off, its job is done. And finally, the original untagged data is sent out the right access port, arriving safe and sound at a device in VLAN 10. So if there's one thing you take away from all this, it's that the VLAN ID inside that little tag is everything. It's the set of instructions that tells the receiving switch exactly what to do and where to send that frame. No confusion, no mix-ups. Okay, so you know how in networking, for every rule, there's always an exception? Well, here it is. For trunking, that exception is called the native VLAN. It's a special little setting for just one of the VLANs on that trunk. So what's the deal with the native VLAN? Well, it's mainly there for backwards compatibility, for older gear that just doesn't understand these tags. Any traffic in the native VLAN gets to cross the trunk without a tag. By default, this is almost always VLAN 1. But here's the golden rule, the one thing you have to get right. The native VLAN has to be the same on both ends of the trunk. If one switch thinks it's VLAN 99 and the other thinks it's VLAN 1, you are going to have a bad time. Traffic can actually jump between VLANs, which can cause all sorts of weird security problems and headaches you do not want to deal with. All right, that was a lot of info, so let's take a breath and put everything side by side. Let's do a quick, clear summary of these two port types we've been talking about: access versus trunk. It really just boils down to this. An access port, it's for one VLAN, only one. All the traffic is untagged, and you use it to connect things like your computer or a printer. A trunk port, it carries multiple VLANs. The traffic is tagged, with that one exception for the native VLAN, and its main job is to link your switches together. Seriously, getting this difference down is one of the most fundamental things in networking. So why do we care so much about this? Why is it so important? Honestly, trunking is what makes our modern networks even possible. Without it, your VLANs would be stuck, trapped on just one switch. You could never build the huge, scalable, and super flexible networks that every single business and data center depends on. Okay, but I have to leave you with one last super important reminder. Please remember this. All that trunking does is extend your VLANs from one switch to another. It just lets a PC in VLAN 10 on switch A be on the same network as a PC in VLAN 10 on switch B. That is all it does. It absolutely does not let VLAN 10 talk to VLAN 20. That separation, that wall between them, is still 100% there. And that, of course, brings us to the final burning question of our series. If VLANs are built to be separate, and trunking just makes that separation bigger, then how on earth do they ever communicate with each other when they need to? Well, we're going to answer that in part 4 when we jump into the world of inter-VLAN routing. I will see you there.